Now we are moving on to the topic that says equation of a straight line in different forms. First of all, we will study about the equation of a straight line in various forms. Before we start, we have two basic forms of lines. Those are equation of line that is parallel to x-axis and equation of a line that is parallel to y-axis. So these two are very simple and very basic. First of all, I'll just explain you equation of a line that is parallel to x-axis. So this is the x-axis we know, and this is the y-axis. So I'm just going to draw a line, any line that is parallel to x-axis. Okay, so say that this is the line that is parallel to x-axis. Okay, how do we write the equation of this line in this Cartesian coordinate system? So if you see over here, for this line, this distance from here to here, it's always constant, is it? Right? This distance is always constant. So what is this distance? This distance is distance up to here, which is equal to, this is the y coordinate or the y-intercept, right? If we say that this is the y-intercept and this line is never going to meet the x-axis, so there's not going to be any x-intercept, right? So this always and always, the equation of this line is going to be y equal to c, where c is the y-intercept. Y equal to c, and where c is the y-intercept. This is how we write equation of a line that is parallel to x-axis. And now equation of x-axis itself is y equal to 0. If y is equal to 0, this line says y is equal to 0. So the equation of x-axis is y equal to 0. This line would be y equal to this distance, whatever this distance is. Let's say that this distance is c. So this is y equal to c. That is the equation of this line. Okay. And now what I'm going to do is I'm going to erase this and I'm going to draw a line parallel to y-axis, because the next thing is that we have to find the equation of a line that is parallel to y-axis. Okay. So let's say again we have this Cartesian coordinate system, and what I do is I draw a line that is parallel to y-axis. Okay. So here is a line parallel to y-axis. Okay. So what is the equation of this line? Same as we found that this is going to have an x-intercept but no y-intercept, and let's say that this x-intercept is again c, right? So the equation of this line is going to be x equal to c, where c is the x-intercept. Right? Easy enough. And the equation of y-axis itself will be equation of y-axis is equal to x equal to 0. Equation of y-axis will be x equal to 0. That is it. So we have equation of line that is parallel to x-axis and equation of line that is parallel to y-axis. And we have also found the equation of x-axis and y-axis themselves. Okay. So now we'll be moving on to three different forms of equations of straight lines that we have in our syllabus. First is slope-intercept form, second is point slope form, and the third is two-point form. So I'll tell you how are these formed and the end results of them. Okay. So for slope-intercept form, just have a look at this figure over here. This is again a Cartesian system. This is the straight line we are talking about. All the things that we know are, I'll just write what all is given. Okay. First, it is given that the y-intercept is equal to c. This is the y-intercept. This line meets y-axis at point B, and the y-intercept is this distance that is equal to c. Okay. What does the heading say? It says slope-intercept form. So what all is going to be in this form? There's going to be a slope and there's going to be an intercept. So the y-intercept is equal to c and the slope is equal to, say, m. We are assuming the slope equal to m. What does this mean? This means that tan of theta is equal to m, right? That is what slope is, right? Tan of the inclination, tan of the angle, that is equal to, angle is theta, right? The angle it makes with the x-axis is theta. So tan theta is equal to m. This is all we know, right? So now what I'm going to do is that I'm going to form a form which has y, x, m and c in it. Okay, so how do we start? So first of all, what I say is that we find the distance, we find this value of this bn. Okay, so if you see, bn can be written as equal to, if you see over here, this distance bn is equal to x. Why? Because this is x, this distance is x, this distance I mean, because this is a straight line and this point is x comma y. So its x coordinate is x and the y coordinate is y. So if the x coordinate of this point is x, so the x coordinate of this point is also going to be x. So this line's length will also be x, right? So bn is equal to x, okay? And tell me the length of, let's say that this point is point P. Tell me the length of NP. NP. What is the length of NP? This whole MP is equal to y, right? First of all, it is equal to MP minus MN. Am I right? NP is equal to MP minus MN, right? So what is the length of MP? MP is y and MN is c. Am I right? So NP is equal to y minus c. This is what we get, right? So from here, I say that if you look over here, tan theta is perpendicular upon base, which is equal to NP upon Bn. Tan theta is equal to NP upon Bn, which is equal to, what is NP? NP is y minus c upon x. Okay, tan theta is equal to m, right? So from here, m is equal to y minus c upon x. This is what we get. From here, what do I do is, I take x to this side. So this is mx is equal to y minus c, right? So from here, if we rearrange this, we get the form y is equal to mx plus c. I've just taken c to the side and then rearranged. The line is y is equal to mx plus c. So over here, if we put any values of x and y, we can find the equation of the line. That is it. Very simple, right? So I get this line. We should know m and we should know c to find the equation of this line, right? So the equation of this line is, what is the slope-intercept form? It is y is equal to mx plus c, right? Done that. The second is point slope form. So in this, again, from the name, you understand that it is going to be about one point and one slope. There is not going to be an x-intercept, right? Now from the slope-intercept form, we know that a line can be written as y is equal to mx plus c. Okay. Now if we know that there is a point x1, y1 which lies on this line, a point x1 comma y1 lies on the line. So it is, that point is going to satisfy this equation. So this equation is going to become y1 is equal to m into x1 plus c. Am I right? Now let's see, let's take this equation as equation 2 and let's take this as equation 1. And now what I'm doing is I'm subtracting 1 from 2. Subtracting 1 from 2. So 2 minus 1 can be written as Tell me what will it be? It will be y minus y, y1 minus y, right, is equal to m into x1 minus x. And this c and this c gets cancelled. So y1 minus y is equal to m into x1 minus x. Or this can also be written as y minus y1 is equal to m into x minus x1. These are both the point slope form. See, it has one point, that is x1 y1, and it has one slope, that is m. Okay, so this is the point slope form. Okay, so for the third one, that is 2-point form, what I'm going to do, okay, I can just continue this form over here, right? What I'll do is I'll just divide this board, okay, and I'll continue this form over here. So this is the 2-point form. Now from this form, from this name, you can guess that this point, this form is only and only going to have 2 points. It is not going to have any intercept or any slope, right? So how am I going to start is that I have a form, I have a line, equation of a line which says y1 is equal to mx1 plus c, right? This is the equation of a line. Am I right? Right? This is the equation of a line that is equal to y1 is equal to m into x1 plus c, right? Now, if you see over here, what I am going to do is that I am going to, first of all, erase this because I spoke wrong. This is the equation of a line which says y minus y1 is equal to m into x minus x1. Okay, this is equation of a line for which we know that x1 y1 is a point on that line. Now for this 2-point form, first of all, we know that x1 y1 and x2 y2 lie on the line and hence satisfies the line. So if x1 y1 and x2 y2 lie on the line, they satisfy the equation of the line. So let's say the equation of the line is y minus y1 into m into x1 x minus x1, where m is the slope and y1 x1 are the coordinates of one point that satisfy the line, right? So that can be written as y minus y1 is equal to m into x minus x1. So what I'm going to do is that I am going to substitute x2 minus x2 y2 at the place of y and x. Why? Because this point also satisfied the line, right? So I'm going to just substitute this over there. So this becomes y2 minus y1 is equal to m into x2 minus x1, right? From here the value of m is equal to y2 minus y1 upon x2 minus x1. Now we've got the value of m, right? And we can substitute this value of m, okay, at a place where we have only m and 1 point. So this is a form where we have 1 point and only m. Am I right? Only m and 1 point. So if we substitute this value of m in this equation, we will get a form in which we do not have any slope or any intercept. We only have 2 points. So I will just write it down for you. Substituting this value of m in this equation, or let's say in this equation. So what do we get? We get y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. So this form over here is a 2-point form. So slope-intercept form is y is equal to mx plus c. Point slope form is y minus y1 is equal to m into x minus x1. And the 2-point form is y minus y1 is equal to, this is the value of the slope, that is y2 minus y1 upon x2 minus x1 into x minus x1.